Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe.
The stars have always called to us, their distant light, a whisper of secrets we've longed to unravel. Out there, in the endless dark, a tiny spacecraft, Voyager 1, has been sailing for nearly half a century, carrying humanity's dreams beyond the reach of our sun. It's the farthest thing we've ever sent into the void, a lonely ambassador now drifting more than 15 billion miles from home, where sunlight is a faint memory, and the planets we know are mere specks in the cosmic rearview. For years, it's been sending back whispers of the unknown. But in 2025, after months of garbled silence, Voyager 1 spoke again, and what it revealed has left us breathless. This isn't just a discovery. It's a mystery that's forcing us to question everything we thought we knew about our place in the universe. It's as if we've touched the edge of our solar system and found not a wall, but a living, pulsing membrane. An impossible structure that feels almost alive. This is the story of Voyager 1's impossible find, a tale that begins with a faint signal from the abyss and ends with a truth that might change how we see the stars forever. Picture it, a spacecraft no bigger than a small car, launched in 1977 when disco ruled the airwaves and computers were the size of rooms. Voyager 1 was built to explore the outer planets, Jupiter, Saturn, and beyond, before slipping into the great unknown. Its builders at NASA never dreamed it would last this long, its radioactive heart still beating faintly after all these years, powering instruments that peer into the dark like weary eyes. In 2012, it crossed a line we'd only theorized, the Heliopause, the invisible boundary where the sun's influence fades and the interstellar void begins. This is where our solar system ends, or so we thought. A place where solar winds slow, mingle with the cosmic currents, and surrender to the vastness beyond. Scientists imagined it as a turbulent frontier, a chaotic swirl of plasma and magnetic fields, like a stormy sea meeting an endless shore. But Voyager 1, battered and ancient, found something else entirely. Something that doesn't fit. Something that feels almost too perfect to be real. The signal came slowly, trickling across the unimaginable distance of 15 billion miles. A journey that takes light over 22 hours to complete. Voyager's plasma wave system and magnetometer, instruments designed to measure the invisible forces of space, began painting a picture that no one expected. The data suggested a magnetic field unlike anything we'd seen before, not the wild, tangled chaos of the Heliopause models, but a pattern, ordered and rhythmic, like the steady pulse of a heartbeat. It rippled and oscillated, stable in a way that seemed impossible for a region ruled by searing plasma and cosmic turbulence. At first, the scientists at NASA's Jet Propulsion Laboratory thought it was a mistake. Voyager 1 is old, its systems stretched beyond their limits, its memory fading like an aging explorer's. They checked and rechecked, calibrating instruments that hadn't been touched in decades, comparing the data to Voyager 2's readings from its own distant path. But the signal held true. Something at the edge of our solar system was behaving, not like a roiling river, but like a woven tapestry, precise and deliberate. This magnetic structure, what some are cautiously calling a lattice, is unsettling in its elegance. It's not just that it's orderly, it's that it seems to repeat, forming patterns that stretch across vast distances, like the architecture of a cathedral carved from invisible forces. The field lines align in ways that defy the randomness of high-energy plasma, almost as if they've been arranged. Their oscillations humming at frequencies that don't match any known solar or interstellar process. Imagine standing at the edge of a forest, expecting a wild tangle of branches, and finding instead a garden, its paths laid out with mathematical precision. That's what Voyager 1 has stumbled upon, a cosmic garden at the edge of our sun's domain, where chaos was supposed to reign. The energy signatures are even stranger, hinting at a quasi-crystalline structure, a term that feels more at home in a mineralogy lab than in the vastness of space. It's as if the heliopause isn't just a boundary, but a membrane, alive with purpose, filtering and shaping the forces that pass through it. The scientists are rattled, though they won't say it outright. In private, they admit the data doesn't fit neatly into any model we have. The heliopause was supposed to be a messy transition, a place where the sun's magnetic grip weakens and the interstellar medium takes over. But this lattice suggests something more. A dialogue between our star and the cosmos beyond. A dance of forces we didn't know existed. Some researchers whisper about dark matter, that invisible scaffolding of the universe, wondering if its elusive particles could be weaving these patterns. But dark matter, as we understand it, doesn't behave this way. It's too aloof, too indifferent to form such delicate structures. Others speculate about an interference pattern, a clash between the sun's magnetic field and some unknown interstellar force, like two rivers meeting to form a standing wave. If that's true, it means our sun's influence reaches farther and in more complex ways than we ever imagined, its voice carrying across the void in ways we're only now hearing. What makes this discovery so haunting is its implications. If the heliopause is not just a ragged edge, but a structured interface, what does that mean for our solar system? For years, we've pictured it as a bubble, a fragile shield against the cosmic winds. Now, it feels more like a skin, sensitive and responsive, shaping and being shaped by the universe beyond. This isn't just about physics, it's about identity. Our solar system, our home, might not be a closed fortress but a living thing, part of a larger cosmic ecosystem. The magnetic lattice could influence how matter and energy flow between stars, affecting everything from the birth of new worlds to the cosmic rays that rain down on Earth, subtly nudging climate, biology, even the spark of life itself. It's a reminder that the universe is not a collection of isolated parts, but a tapestry, each thread woven into the next. And then there's the question no one wants to ask aloud. Could this be more than nature's handiwork? The precision of the lattice, its eerie coherence, has sparked whispers among the boldest minds. For decades, some have dreamed of finding signs of intelligence not in radio signals or ancient ruins, but in the very fabric of the cosmos, fields or forces shaped by minds far beyond our own. Most scientists dismiss this as fantasy, and rightly so. The universe is vast and strange enough without invoking aliens. Yet, even they admit the lattice feels uncanny. Its order too pristine for comfort. It's not evidence of anything, not yet, but it's a puzzle that doesn't sit easily, a shadow that lingers in the data. Voyager 1, drifting silently in the dark, has touched something we don't understand. And it's hard not to feel a shiver of awe. And maybe, just maybe, a flicker of fear. This is only the beginning. The story of Voyager 1's discovery is still unfolding. Its data a faint thread connecting us to the edge of the known. As we listen to its whispers, we're reminded of how small we are, how vast the universe, and how much it still has to teach us. The stars have always been storytellers, and Voyager 1 is their latest messenger, carrying a tale that's only just begun to unfold. The signal from Voyager 1 hums across the void, a fragile thread of data weaving its way through the interstellar dark. It's 2025, and this tiny spacecraft, launched when the world was still reeling from the Beatles' breakup, has become humanity's farthest-reaching hand, touching a boundary we once thought was the end of our sun's story. But what it's found at the heliopause, this ordered, almost living magnetic lattice, has turned that ending into a new chapter, one filled with questions that tug at our hearts and minds. It's not just a scientific puzzle. It's a mystery that feels personal, as if the universe is whispering something about who we are and where we belong. As Voyager's faint voice grows clearer, we're drawn deeper into a cosmic enigma, one that challenges our understanding of the stars, the spaces between them, and maybe even the possibility of something or someone else out there. The Heliopause was supposed to be a chaotic no-man's land, a place where the sun's warm breath fades into the cold embrace of the galaxy beyond. Scientists had spent decades modeling it, imagining a turbulent zone where solar winds crash against interstellar currents, creating a frothy, unpredictable boundary. But Voyager 1's instruments tell a different tale. The magnetic lattice it's detected isn't just orderly, it's dynamic, pulsing with a rhythm that feels almost deliberate. The field lines don't twist and tangle as expected. They align in precise intervals, like the strings of a cosmic harp, vibrating at frequencies that defy our understanding of plasma physics. It's as if the Heliopause isn't a wall, but a membrane, sensitive to the touch of forces we can't yet name. And as Voyager drifted through this strange region, it picked up something else: low-frequency radio emissions, faint but unmistakable, that seemed to dance in step with the lattice's oscillations. These radio signals are a new layer of the mystery, and they've set scientists' imaginations alight. At first, the team at NASA thought they might be echoes of solar activity, perhaps a flare or a storm from our star reaching out across the years. But the timing didn't match, and the signal's modulation, the way they rose and fell, was too structured, too purposeful to be random noise. They appeared strongest when Voyager passed through the densest parts of the magnetic lattice, as if the field itself were singing, its vibrations rippling through the plasma like a song carried on the wind. Some researchers wonder if this is a natural phenomenon, a kind of plasma resonance we've never seen before, born from the interplay of solar and interstellar forces. If so, it could unlock new insights into how stars communicate with the cosmos, their magnetic fields weaving invisible threads across the galaxy. Others, though, can't shake the feeling that the signals feel crafted, their patterns hinting at a complexity that nature alone might not explain. This is where the story takes a turn toward the profound and the unsettling. The magnetic lattice and its accompanying signals suggest that the Heliopause isn't just a passive boundary. It's an active interface, a place where the solar system and the interstellar medium don't just meet but interact. Voyager's data shows sharp changes in the flow of cosmic rays, those high-energy particles that zip through space, born in the hearts of exploding stars or the edges of black holes. As the spacecraft crossed through the lattice, some rays passed through easily, while others were deflected, almost as if the field were a selective filter, choosing what could enter our solar system and what could not. This isn't how boundaries are supposed to work. They don't sort and sift like a living gatekeeper. Yet, that's exactly what the Heliopause seems to do, acting less like a wall and more like a skin, responsive and discerning, shaping the cosmic environment within and beyond. The implications ripple outward, touching everything from the practical to the philosophical. If the Heliopause is a dynamic membrane, it changes how we think about our solar system's place in the galaxy. For years, we've seen it as a bubble, a self-contained haven shielded from the interstellar wilds. Now, it feels more like a cell in a vast cosmic organism, its boundaries permeable and interactive, part of a larger flow of energy and matter. This could affect how stars form, how cosmic rays shape planetary atmospheres, even how life itself emerges. Cosmic rays, after all, play a subtle role in Earth's climate and biology, their high-energy particles nudging molecular bonds in ways that might have sparked the first fragile chains of life. If the Heliopause regulates these rays, it might be a silent guardian, shaping the conditions that allowed us to exist. Suddenly, the edge of our solar system feels less like an end and more like a cradle, a place where the universe's forces converge to nurture, or perhaps to control, what lies within. But what's shaping this lattice? That's the question that keeps scientists awake at night. One theory points to an interference pattern, a delicate balance between the sun's magnetic field and an unknown interstellar force. If true, it means our star's influence stretches farther than we thought, its magnetic voice echoing across distances we can barely fathom. Another idea, bolder and less certain, suggests dark matter might be involved. Not the inert, invisible stuff we've modeled, but something more active, weaving filaments of gravity or energy that sculpt the Heliopause's structure. Yet dark matter remains a ghost, its nature so elusive that this theory feels like grasping at shadows. And then there's the idea no one wants to say too loudly. What if this isn't natural at all? The lattice's precision, its almost geometric perfection, has sparked whispers of intentionality. Could an advanced civilization, light years away or long extinct, have shaped these fields, leaving behind a cosmic signature, not of stone or metal, but of energy and order? Most dismiss this as science fiction, but the data's eerie coherence lingers. A puzzle piece that doesn't fit anywhere we expect. These questions aren't just academic, they're human. They touch on our deepest curiosities, our longing to know if we're alone, if the universe is a place of chaos or purpose. Voyager 1, with its fading power and ancient circuits, has become more than a machine. It's a storyteller, carrying tales from a realm we may never reach in our lifetimes. Its discovery has practical consequences too. If the Heliopause is structured and active, it changes how we design future missions. Spacecraft heading for the stars might need to navigate this lattice, using its patterns as a map, or shielding against its selective filters. The magnetic fields could disrupt navigation systems, or, if we learn to read them, guide us like a celestial compass. And if those radio emissions are a form of resonance, they might inspire new technologies, from interstellar communication to propulsion systems that ride the waves of plasma, like ships on an ocean. The story of Voyager 1's find is also a reminder of our own fragility and ambition. This spacecraft was built by hands that no longer worked the same controls, by minds that dreamed of a future they'd never see. Yet it endures, a testament to what we can achieve when we dare to reach beyond our grasp. Its discovery at the Heliopause feels like a gift, a glimpse of a universe that's stranger and more beautiful than we imagined. But it's also a challenge, urging us to look closer, to listen harder, to question what we think we know. The lattice, with its rhythmic pulse and mysterious signals, is a doorway to new truths about our star, our galaxy, and maybe even the forces that shape existence itself. As Voyager 1 drifts farther, its voice growing fainter, we're left with a sense of awe and unease. The Heliopause, once a distant concept, now feels alive. A boundary that doesn't just separate but connects. A place where the sun and the stars whisper to each other in a language we're only beginning to hear. This is more than a discovery. It's an invitation, a call to keep exploring, to keep dreaming, to keep asking what lies beyond the edge of everything we know. Voyager 1's faint signal flickers like a candle in the cosmic night, carrying a story that has already reshaped our view of the stars. Out there, at the Heliopause, where our sun's embrace fades into the interstellar unknown, this aging spacecraft has uncovered a magnetic lattice, a structure so ordered, so alive with possibility, that it feels like a message from the universe itself. It's 2025, and as we listen to Voyager's whispers, we're not just unraveling a scientific mystery. We're standing at the edge of something vast, something that touches the very essence of our existence. This is the final chapter of Voyager's impossible discovery, a tale that weaves together awe, ambition, and the eternal human hunger to know what lies beyond. It's a story that doesn't end with answers, but with a challenge, to dream bigger, to reach farther, and to embrace the wonder of a universe that refuses to be tamed. The magnetic lattice, with its rhythmic pulse and eerie radio emissions, has already turned our understanding of the heliopause upside down. What we once saw as a chaotic frontier now feels like a living boundary, a cosmic skin that breathes and responds to forces we're only beginning to grasp. But as scientists dig deeper into Voyager's data, the implications grow even more profound. This isn't just about our solar system. It's about the galaxy, the stars, and the invisible threads that bind them. The lattice suggests that stellar boundaries might not be walls, but interfaces, places where energy and matter flow in ways that could shape entire worlds. If every star has a heliopause like ours, woven with ordered fields and selective filters, then the galaxy itself might be a network, a tapestry of interconnected systems, whispering to each other across the void. This idea transforms our view of the cosmos from a collection of isolated lights to a living, breathing whole, where our sun is just one voice in a galactic choir. The cosmic rays Voyager detected, those high-energy particles that dance through the lattice, add another layer to this vision. Their selective filtering at the heliopause hints at a boundary that doesn't just protect but curates, deciding what enters and what stays out. This could have shaped Earth's history in ways we're only now beginning to suspect. Cosmic rays, after all, aren't just travelers. They're catalysts, their energy nudging the delicate chemistry of atmospheres and oceans. They might have sparked mutations that led to life, or shifts in climate that sculpted our planet's story. If the heliopause has been quietly regulating these rays for billions of years, it's not just a boundary, it's a guardian, a silent partner in the dance of existence. And if other stars have similar boundaries, they might play the same role, cradling the potential for life in ways we've never imagined. Suddenly, the search for life elsewhere feels less like hunting for a needle in a haystack and more like listening for echoes in a vast, interconnected web. But the lattice's mystery doesn't stop at science. It reaches into the realm of dreams and fears. The radio emissions, with their structured modulation, continue to haunt researchers. Some see them as a natural byproduct of the lattice's vibrations, a kind of cosmic hum born from plasma resonance. If true, this could revolutionize our understanding of interstellar physics, even inspiring technologies that harness these waves for communication or propulsion. Imagine spacecraft that surf the magnetic currents of the heliopause, or signals that travel vast distances by riding the galaxy's invisible strings. Yet others can't shake the feeling that the signals are too precise, too deliberate. The idea of an artificial origin, however unlikely, lingers like a shadow. No one's claiming aliens, not seriously. But the lattice's geometric perfection and the signal's eerie coherence keep the question alive. What if we're not just hearing the universe, but something within it? It's a thought that sends a shiver down the spine, not of fear, but of possibility. This discovery also forces us to rethink our future among the stars. The heliopause, with its structured fields and dynamic filters, isn't just a milestone. It's a challenge. Future missions will need to navigate this region, not as a barrier to punch through, but as a landscape to explore. Scientists are already dreaming of probes designed to linger at the heliopause, mapping its lattice like cartographers charting a new continent. These spacecraft might need shielding to withstand the magnetic currents, or sensors to read the lattice's patterns like a cosmic map. They could even use the heliopause's resonance to guide their path, steering through the galaxy's currents like sailors following the stars. And if we learn to interact with these fields, to nudge or shape them, we might unlock new ways to travel, to communicate, to exist beyond our sun's embrace. The heliopause, once the end of our journey, could become a gateway to the stars. Yet, for all its promise, this discovery carries a weight of humility. Voyager 1 is a relic, a time capsule from a world that no longer exists. Its builders, engineers and dreamers who worked with slide rules and punch cards, couldn't have known it would touch the edge of the unknown. They sent it out with a golden record, a message of music and greetings, hoping it might one day be found by someone or something else. Now, as Voyager drifts through the lattice, its fading voice feels like a bridge between their dreams and ours. It reminds us that exploration isn't just about conquering distance. It's about carrying our humanity into the dark, about asking questions even when the answers are uncertain. The lattice, with its beauty and mystery, is a testament to that spirit, a reminder that the universe rewards those who dare to look beyond the horizon. And what of Voyager itself? Its power is waning, its radioactive heart growing cold. In a few years, perhaps by the end of this decade, it will fall silent, drifting forever through the interstellar void. But its legacy will endure, not just in the data it sent back, but in the questions it sparked. The lattice at the Heliopause is a new frontier, one that will draw us forward, urging us to build new machines, to tell new stories, to reach for the stars with bolder hands. It's a reminder that boundaries, whether of Earth, sky, or solar system, are never endings, but invitations. Each one we cross reveals a world more complex, more mysterious than the last. The Heliopause, with its living membrane and cosmic song, is no different. It's not the edge of our story, it's the beginning of a new one. As we stand here, gazing up at the stars, Voyager 1's discovery feels like a gift and a challenge. It tells us that the universe is not a place of chaos, but of order and wonder, where even the boundaries sing with purpose. It asks us to keep listening, to keep exploring, to keep dreaming of what lies beyond. Whether the lattice is a natural marvel or something more, it's a reminder that we're part of something vast, something that connects us to the stars and to each other. Voyager 1, our lonely traveler, has touched the skin of the cosmos and found it alive. Now it's up to us to follow, to carry its story forward, and to write the next chapter in humanity's great adventure among the stars.